This is video 3 of looking at random variables and probability distribution functions. One of the things I should have pointed out back here in the last example that I didn't is just looking at the sum of these. So if we add these up, notice that 125 plus 75 is 200 plus 16. So we're going to end up with, when we add them up, put little plus signs in here, we get 216 out of 216, which is 1. And remember we said that that's what's supposed to happen, is that those probabilities add up to 1. And also that all of the probabilities are between 0 and 1. In example 2, it says a random variable x has this probability distribution shown, and they want us to find the value of c. Well, remember that all of these probabilities have to add up to 1. So we have 7c plus 5c plus 4c plus 3c plus c, which adds up to 12, 16, 19, 20c. We know that that has to add up to 1. So if we solve that, we end up with c is equal to 1/20. Right. In part B, it says find the probability that x is greater than or equal to 4. Well, that would be these two outcomes. All right. So in other words, it's the probability that x is equal to 4 plus the probability that x is equal to 5. And the probability that x is equal to 4 is 3c. Well, c is 1/20, so we get 3/20. Plus, and then the probability that x is equal to 5 is just 1/20. So it looks like we end up with 4/20 or 1/5. We're going to go on to example 3 also. Actually, we're just going to do 3a for this one. So this says, show that the following are probability distribution functions. So remember, there are two qualities that we have to show if we're going to show that it's a probability distribution function. We have to show that all the probabilities are between 0 and 1, which is what was here. We have to show that all the probabilities add up to 1. So this is just saying that we have a random variable x. I'm actually going to write it this way, since I have this function that I have to substitute them into. 1, 2, 3, 4. And the probability distribution function is x squared plus 1 over 34. So if we substitute each of those in, for the first one, we're going to get 1 subbed in here. So we get 1 squared, which is 1. 1 plus 1 is 2 out of 34. When we sub in the 2, we get 4 plus 1, which is 5 34ths. When we substitute in the 3, whoops, wrong one, 3, into here, we get 9 plus 1, which is 10 out of 34. And when we substitute in the 4, we get 16 plus 1, 17 out of 34. All right, so the first thing to note is that all probabilities are between 0 and 1. That was the first quality of probability distribution functions. The second one is, and note that 2 34ths plus 5 34ths plus 10 34ths plus 17 34ths adds up to 27, 29, 34 34ths, which is 1. All right, so that's what we're looking for to prove that that's a probability